All right, I want to thank everybody for joining us for today's live webinar entitled Creating a Comprehensive R&D Image and Image Data Management Strategy, presented by Bob O'Hara with ResultWorks and Astrix Company. So we can go ahead to the next slide, please. Now, before we get into today's content, I do want to take a few moments to introduce you to Astrix. I'm not sure, obviously, if everybody who's on the call has participated in any of our webcasts or webinars that we've been running. For the better part of the last year and a half here. We do them fairly regularly on a wide array of topics around compliance and lab informatics, obviously all around life sciences. So in terms of who we are as a company, we've been around for 25 years and we bring a very unique breadth of highly specialized services, process and technologies, which has enabled us to become a leading partner in transforming the way science-based businesses succeed. A couple of quick facts about the company. We were established in 1995. We are vendor and platform agnostic. We're a services firm that works with a wide array of lab informatics technologies and other technologies in the space. We operate from locations in the United States and overseas with 1,200 employees, 90% of whom hold advanced science degrees. So Astrix is very much a science-based organization that uses technology to help drive projects forward at our customers. Headquarters are in Red Bank, New Jersey. And in terms of the clients that we serve, everybody from startups up through Fortune 1000. They're going to typically be life science enterprise, chemical, CPG, government agencies, or research institutions. We can go to the next slide, please. The services that I reference, they support the continuum of scientific operations and data management. And what that means is, from the very beginning of a project, we work with companies in the strategic innovation and the roadmaps or enterprise architecture phase. This is where we're really helping folks deliver transformative strategies with roadmaps that address business imperatives geared towards digital readiness. So moving people through a digital transformation process. Enterprise architecture is really helping organizations understand what their technology stack should look like to meet their goals. From there, we get into data management and governance, and then business analysis, ensuring people, process, and technology are optimized. From there, we can go right to solution services selection. And that is where we will piece together the right technologies based on what we've learned from the earlier services that I mentioned. We can do development and implementation and validation. And then finally, at the end of it, if needed, we can even staff your organization with both technical and or scientific professionals. So that's a little glimpse into the services. Obviously, we want to move you into the presentation material. So let me take a moment here and introduce our speaker for today, Bob O'Hara. So Bob is Vice President of Business Development with ResultWorks, which is an Astrix business. Bob's an accomplished senior executive with more than 35 years experience in building and leading organizations, including professional services, product management, and software development. He's managed organizations and projects which have provided information technology solutions, including R&D informatics, lab systems, clinical information management, supply chain, process and manufacturing management. It's my pleasure to introduce Bob. I'll let him take it from here, and I'll circle back on at the end of the sits with questions, Bob.
Thank you very much, Kevin. Pleasure to be here this afternoon. I appreciate everybody spending half an hour with us to hear about imaging and image data management. This is the agenda that I have mapped out for you this afternoon. We'll spend a little bit of time going through some project background and objectives that this presentation is put together from. This is based on some work that ResultWorks had done with a client starting back in 2019. We did some strategy work that year, and then subsequent years worked through a variety of implementation details, and the client is currently continuing to do work through implementation. So we'll go through some of that project background and objectives. We'll talk through some of the current state landscape that we saw. We'll talk about some imaging technology trends that we investigated in the course of the putting together the strategy. We'll talk about some of the solution alternatives that we looked at. And then finally, we'll address some takeaways and outcomes before addressing any questions that may come up in the context of the presentation. So with that as the background, this client had various groups across research and development who were managing images in various modalities. The groups that were involved, there were groups from discovery and lead development. There were groups in pathology, radiology, and biologics. all managing different kinds of images using different kinds of tools and so on. The solutions that they had in place were very decentralized, and obviously, like any informatics-oriented solution, they had evolved to meet the needs of the groups that were using them, both for processing images and ingesting images, managing images and image data, and so on. So the ask was to start to look at consolidation of this, and we had issues as it defines in item 4 there. Very different types of imaging processing, ranging from event-driven image collection and image data collection and analysis, to things like high-volume image processing that you might see more in a high-content screening environment. So that's the range of imaging issues that we were dealing with. So the objective that this client had, that we worked through with them, was really to develop a strategy to complement some of the specialty imaging systems that were being used, and instill a more consistent way to collect images, to store images, to access images for broader use, both of the images and the image data. Image data, think metadata, analysis type data, and that's across the R&D spectrum. At the end of the day, the ask was basically digital everything around imaging and image data management. So that was how we started. If you take a look at the landscape, so again, we were looking at pathology, radiology, high content screening, and then other imaging needs around R&D. So we did spend some time soliciting input from stakeholders in various parts of the organization regarding the challenges that they had in managing images and the associated image data, so that the whole life cycle of the understanding what images that they needed to retrospectively looking at the same images. We created strawman views of the workflows in each of these areas and the associated data flows for each function. And then we compared those workflows across the steps, helping the imaging community kind of get a more holistic sense of the landscape. So that's the backdrop here for the current state. So let me drill into this a little bit. What did we learn from the current state? So on the pathology front, really image acquisition and analysis was both performed in-house and by external third-party labs. For clinical and preclinical workflows, they use similar technologies to support the image management. However, there was really no standard image format. There were several proprietary formats that were being used, but again, nothing standard. Images were stored in repositories or on network file shares, but nothing terribly consistent. The performance was an issue, and image handling created some capability gaps that the client wanted to address. And then external image and image data transfers were all done via Amazon Web Services. So that was a snapshot of the pathology area. On the radiology side, the clinical work was really all done by third-party labs. So consequently, the images were all external. Preclinical imaging was done in-house, or largely in-house. Some was outsourced. And then clinical and preclinical used the same technology to support image management. So images were in a DICOM format, and image transfers used DICOM protocols, and the relevant images that needed to be saved were archived in a commercial image management metadata management system. So that was in pretty decent shape at the end of the day. And on the high content screening side, there were variable source systems generating images. Instruments, however, tended to generate their own proprietary file formats, which is problematic in pretty much everything we do. And metadata wasn't always collected, and if it was collected, where it was collected, it was done inconsistently, not really following any standard practices. And then analysis were conducted across different groups using numerous tools. So quite a number of issues there in the high content screening area to be addressed. And then in other areas of discovery, toxicology was using a commercial tool for digital slide management, as was the safety group. And then the toxicology and the therapeutic areas were using camera-enabled microscopes but really no formal image repository, which again was problematic. So that was the landscape. What were the needs associated with that? So on the pathology side, we really came to the conclusion that we needed to replace the then current tool. We needed better metadata handling to accommodate the functionality that we were looking to support. We needed better performance out of the tool. We needed to deal with multiplex fluorescence images. We needed to accommodate multiple image formats. We needed more complete integrated metadata management environments. So for things around experiments or samples or stains and so on. So that needed better management across the board. On the radiology side, we needed a more complete and automated metadata management capture environment. We needed more automation of the ability to move images, get images to other user communities who wanted to look at images on a secondary basis. On the clinical side, really the application that was being used was doing a reasonable job, but to scale it, we just needed to move it into a cloud-based environment. So that was not going to be too heavy a lift to accommodate the clinical side of radiology. In the high content screening area, however, we needed a commercial instrument platform and software for high content screening images. We needed platforms to output in a more common image formats with standard metadata. We needed to adopt industry standards for multidimensional well images. We needed a common image repository. We needed image transfers into formats needed by third-party analysis tools to enable the researchers to be versatile in how they were looking at their images and what tools they were able to use. In common across all of these areas, we recognized that we needed scalable, cost-effective, cloud-based image management to store those images and support global sites that were all generating and using and viewing images. We needed a single logical repository and the ability to search that repository. We needed more automation around image ingestion, around piping images into tools for analysis, around using AI and ML tools and other evolving technology. We needed to standardize on ontologies and vocabularies across the company so that it would be easier to find and link and search and then access images. So that's the backdrop of needs. As we laid out the workflows and then started to compare the workflows, you look at all these different groups generating and doing work with images, and the workflows are generally pretty consistent. People are doing work requests, they're doing sample prep and management, they're acquiring the image and doing analysis, they're generating results, analyzing the results, reporting on the results, they're storing the image and the image data. So generally, things are pretty consistent at this level. So at the high level, the workflows are in common. It's in the detail as you start to get down into the modalities where things start to fall apart or differentiate a little bit more. So that's kind of a frame of the current state. As we get into looking at other technology trends, we did spend some time looking at technologies that were evolving elsewhere in the industry. So we looked at things like integrity, authenticity, and confidentiality of images. So if you think about medical imaging in particular, being able to really tie an image to a patient, so medical image watermarking or use of blockchain for secure sharing of medical images associated with a patient. You don't want to lose track of those kind of things. So we looked at that. We looked at image analysis, the ability for reproducible image analysis, for container-based image analysis, using deep learning tools. We looked at augmented and virtual reality around sample management and the ability to visualize images for a kind of a different view, a deeper view into images or territories of the image. We looked at semantic image annotation and ontologies to better earmark regions of interest in an image, make annotations on the image more meaningful and more specific. We looked at image management and viewing tools, things like zero footprint image viewing and content-based image retrieval. We looked at vendor neutral archives. We also looked at other industries. We looked at the photography industry. We looked at imaging around drones. We looked at imaging around autonomous vehicles and for applicability into these areas, into pathology, radiology, high content screening applications. And, you know, bottom line, we didn't find any holy grails out there. We found that some of these emerging technologies were showing some applicability for what we were doing or what we are going to need in the future. But it's really kind of early days for a lot of the technologies, use of blockchain, use of augmented reality, virtual reality tools and deep learning tools. The tools are getting better. The technologies are expanding. They're finding better homes and better uses in image analysis, but they weren't quite there yet for our specific applications. And the trends that were really progressing the fastest were focused on medical imaging use cases, not necessarily on pharma R&D type use cases for our purposes. We also were hoping for, not with a lot of hope, but we were hoping for an off-the-shelf commercial platform that we might have adopted, but we didn't find anything in other industries that could readily be adopted into the pharma or medical imaging domains. So that hope went a little bit wanting at the end of the day. So that was a look at the trends. A fair amount of work done in that area with drill down. So then we started looking at so how do we get to a solution in this space? So we looked at a number of different options. Number one, we were hoping for the ability to implement a single commercial solution to address all of the modalities that we had, pathology, radiology, high content screening, and so on. If we didn't find that, we were going to drop back to looking at existing applications and potentially leveraging those existing applications to cover additional domains. So move the pathology application into radiology or backwards or whatnot. So we'll talk a little bit about that. Or at a minimum, kind of a common shared supporting foundational set of services that could be applied to pathology, radiology, and high content screening. And then on D here, we recognize that there were still going to be some unique needs in certain areas of the business that we needed to address with site-specific needs. So regardless of the solution that was selected, we were going to have to do some work to cover the unique needs for specific applications. At a minimum, we wanted to identify needs across the modalities that would allow for or lead to more consistent collection, storage, and accessibility of images and image data across R&D. So that was kind of the bottom line need, going back to our original objective for what we were hoping to get out of the project. Regarding the single commercial solution, unfortunately, there was just no one-size-fits-all solution to cover all the capabilities we needed across radiology, pathology, and high-content screening. The commercial solutions that we found were really very modality specific and wouldn't support all the capabilities needed by the other modalities. So basically the ologies are different enough that it made it too difficult for one application to cover others. So we realized pretty early on here, as we were in the solution mode, that a multi-solution approach was going to be needed. We looked at the possibility of extending the current radiology solution because that was the one that was at least working in the clinical space pretty well, just needed to be scaled into a cloud-based environment. But we found that extending that to non-DICOM oriented workflows and communications and image viewing that would be needed for pathology, for example, was not going to be easy to get to. And we knew that we were never going to get there on the high content screening images and workflows. So that just wasn't going to adapt. The pathology solution, again, we knew pretty early on that already needed to be replaced. So looking at that and trying to extend that to other areas also wasn't going to work. So we gave up on that option of extending solutions that were already working in some of the areas to some extent. As far as common shared services, foundational services, we did recognize that we could drive certain things in common across modalities. So metadata could be driven to be more common. Results management could be more common. Digitized images, the way they're ingested and processed and stored, the way the analysis or piping to analysis tools or storage of images or libraries of images or the use of viewing tools. Those were areas that did yield some results and some interest and some ability to stand up and support across all of the modalities. So we spent most of our time in the solution process here. And then finally, in the function specific, we knew that whatever solution we picked in each of the modalities, there was still going to be more adaptation needed, if you will, based on select domain areas or geographies or certain unique workflows that needed to be supported. And we expected to do that during the design and implementation once the solution had been selected. So where did we wind up in each of these areas? So for the cross-modality approach, we did wind up with a combination of approaches. We wound up on the common shared foundational services with things like common storage management, along with services to support modality-specific image processing, image management, workflows, and so on. With high content screening, we did get to the point of centralizing high content screening storage, image storage. We did get to automate movement of images from platforms to acquisition and adding enhanced metadata into a common image file format. We did get to a better place around storing images and image metadata in a common repository. We did get to a common set of viewing tools that could be used by various applications and reference back to the common image repository. And then we also work through automation pipelines to convert images for use in various analytics tools that were used by the high content screening groups. On the pathology side, we were able to select and implement a pathology cloud-based solution for image and image metadata management, viewing and annotation. And we were also able to develop and deploy metadata services to ingest and conform those images and image data. And again, we were also able to develop some analysis pipelines to access the analysis tools around pathology type imaging. And on the radiology side, we were able to redeploy the solution that was already in play on a local basis into a cloud-based environment for scalability. We did some enhancements to that system to work with a common storage architecture, and again, develop some analysis pipelines for automating the analysis process. So that's where we wound up in each of those areas. Kind of graphically looks a little bit like this, kind of high level generalized view of where we wound up. So we wound up with input from a variety of different sources, data files and image files, data in systems, data from instruments, data from external vendors. We brought that into an ingestion area or a landing zone, if you will. We were able to extract metadata from those files and also enhance some of the metadata if metadata was missing. We had some pipelines for processing some of the modality-specific images on the intake. Some of this was married with work that was already going on in the company around informatics data lakes to apply metadata models and ontologies and vocabularies that were already at work. So we were able to leverage that technology and those projects to work with the image processing. Once images and image data was conformed, then it was passed through the various imaging solutions for high content screening for pathology or radiology. And then ultimately the image wound up in a single virtual file system that we were able to support, connected to the physical storage in an Amazon-based environment with various pipes from different geographies. And again, the images were also linked back to the metadata repository. And then on the output side, we were able to develop various pipes that would pipe images into the analysis tools of choice by the researcher or scientist doing whatever kind of image analysis was required. So that's a view, a quick overview on the architecture. We did develop a strategy roadmap as part of this. So we had a high-level roadmap with work streams for each of the modalities and then the common technical environment. These were broken out further into more detail by modality and by the foundational areas. And then each project on the roadmap was broken out into its own kind of project charter or summary level description of the project. So someone picking up the project somewhere downstream would have a starting point indicating what the project should deliver, what it was dependent on, and what the expected outcomes would be of the project. So some key takeaways and outcomes from this. One is that integrating ologies is just really difficult. The technologies and the workflows at the detail level are really very different. And we did not find that any one size fit all of the different applications. We also didn't find any unicorns in other industries that we could readily take and adapt to any one, let alone all of the modalities that we were working with. We did get to the point of alignment, though, across the imaging community in the company around a common strategy to leverage that common technical environment, and then still being able to support the modality-specific technology and workflows. We were able to agree on a prioritized strategy roadmap, defining key activities to implement each of the strategies and each of the modalities. And then ultimately solutions were selected, and the company continues to deploy the imaging functionality across various geographies, across various functions, and leveraging other technical infrastructure and tools where it's already available in the company. So that's all I was expecting to cover today. So I thank you for your attention, and if there are any questions, I'd be glad to address whatever I can.
That's great, Bob. Thank you very much. A couple of quick things here. I'm going to go ahead and stop the recording, so this ends the recorded part of the session.